In this episode of Scaling Postgres, we talk about the worst part, pluggable storage, a busy system, and data architecture. I'm Preston Jameson, and this is Scaling Postgres, episode 264. All right, I hope you, your friends, family, and coworkers continue to do well. Our first piece of content is the part of PostgreSQL we hate the most. This is from ottertune.com, and I believe this might be a follow-on post from something done by Software and Booze last week where he was saying MVCC wasn't so bad, whereas their perspective, it's how Postgres does MVCC that they hate the most. So they go into a lot of depth of design principles and how Postgres is designed, and does a little bit of comparison to how MySQL and Oracle does it. Basically, Postgres does some things that those other two engines don't, and how that can result in your database being larger than it would on those systems, as well as potentially cause some performance problems. So they first described what is multi-version currency control, at least how Postgres does it, and basically when you do an update or delete some sort of modification that's not an insert, it creates an entirely new row in the table. So it copies all the data and puts it in a new row, making the modifications that are necessary, and that is the new version of the row. Now, a downside of this, you could have 1,000 columns in that table, and you only change one value in one column. Well, now you've done all of that duplication. Other engines simply make the change in place and store a delta of what was changed. So that's how you can get your multiple versions. And they talk a little bit about how you chain define the different row versions that exist. And then, of course, with all of these new rows being created, you need a way to eliminate them, and that is the purpose of vacuum. And then they go into the section about why PostgreSQL's MVCC is the worst. One is the version copying, so the copy of the entire row as opposed to just deltas, like I mentioned before. This results in table bloat. You have all of these rows in the database, and that can impact things like full table scans because you have all these other dead rows if it's not taken care of. And then even after you vacuum those rows, it doesn't reclaim space. So your data files are much larger. Now you can recreate indexes to make those smaller, but the data tables, like they say here, the only thing to do is to basically rewrite the whole file again. And you can do that with the vacuum full, but that locks the whole table for reads and writes. Or you could use the PG repack extension to do it. But again, you need a ton of disk space to be able to do that work. And then the third problem is secondary index maintenance. So all of these different versions have indexes pointing to them as well. And they point out this is part of the reason that Uber in 2016 switched from Postgres to MySQL, is that, quote, their write-heavy workload was experiencing significant performance problems on tables with many secondary indexes. So these are the non-primary key indexes. And the fourth problem is the vacuum management and tuning that appropriately to make sure you don't have tons of dead rows in your tables. So this was a very well-written post, and I really like the perspective that they gave. They really didn't have any solutions. They just kind of state this is essentially the state of things. But they did mention something that I covered last week, or I brought up last week when doing the MVCC article, and that was zheap. And here they say, quote, there was an attempt to modernize PostgreSQL's version storage implementation, so to make some of these problems better. Enterprise DB started the zheap project in 2013 to replace the append-only storage engine to use Delta versions. Unfortunately, the last official update was in 2021, and to the best of our knowledge, the effort has fizzled out. So that's the perspective of this post. And again, I highly encourage you to check it out. But the next post on this topic is Next Steps for Postgres Pluggable Storage. This is from supabase.com. And they're covering this issue as well from the perspective of pluggable storage. And those are the APIs that allow different storage engines for Postgres, and what zheap was ultimately going to be, another storage engine that you could choose for your tables. And they mention the current progress for pluggable storage here, in that in version 12, they introduced basic support for pluggable storage and the goal of adding zheap. So there's the zheap reference again. So he says, quote, zheap was released with promising results, providing an undo log and solving some long-term table bloat issues in Postgres. But like the last post, he says, quote, it appears that the work on zheap and the table access method TAM API has stalled. So there are some current issues that kind of need to be addressed before we can make this pluggable storage as good as, if not better, the current storage technique. Now, one interesting thing they mention here is that OrioliDB started as a fork of Postgres to address many of their perceived issues of Postgres and have been quietly upstreaming code that would make pluggable storage a reality. So they say in Postgres 14, their patch set was 5,000 lines of code, representing the total number of changes required in their fork. In the upcoming Postgres 16 release, it is 2,000 lines of code. So that means basically 60% of the code changes to achieve what they're trying to achieve with OrioliDB have already made it into the Postgres core. And they say, quote, disclosure here, Supabase started sponsoring OrioliDB in 2022. So I really like hearing this, and hopefully different members of the community will continue to push forward and make a revamped storage system, or at least storage option, available. But highly encourage you to check out both of these pieces of content. Next piece of content, what does a busy system mean? This is from hdombrovoskaya.wordpress.com. And she's talking about she's working with the database system, and the system gets busier and busier, and the developers need more connections. Well, now you may be running out of memory. And then the DBA looks at the database essentially and it says, well, you've got all these idle connections. What's going on? And she says, quote, the first question we should ask is what makes your system busy? So she said she actually talked to the application developers, showing them the percentage of idle sessions and the resource consumption. And they dropped the average number of connections from 2,700 to a little over 1,000. And she kept insisting continue to work on this. And she says after one more week of digging into the application code, the average number of connections was reduced to 60. So they went from 2,700 open connections to 60. So clearly, as she talks about here, it's an application architecture problem, or there's something in the code causing this problem. And she says something down here that's pretty interesting. Tuning system parameters may improve performance up to 10 times. I frankly usually say 2 times or 3 times if you're lucky. Tuning individual queries may make everything run 10 times faster. That's possible, I think, if the database system is being bogged down by certain queries. I mean, I've definitely seen something like that. But you can definitely get queries 1,000 times faster. But maybe overall that may result in a 10 times faster system. And then in optimizing the system architecture can make things run hundreds to thousands of times faster. So definitely it's clear to see there's always room for optimization. And you don't necessarily have to keep getting bigger servers and more memory and more connections, etc. Next piece of content, thinking fast versus slow with your data in Postgres. This is from crunchydata.com. And this is basically talking about setting up a better data architecture, kind of alluding to the previous post. And he talks about some common workloads for Postgres are basically the primary system of record, primarily an OLTP-based system. You have a metrics, analytics type data you're storing and want to do an analysis of. And then there's logging event-related data. So he thinks there's different ways you can set up each of these 3 different use cases. The primary system of record, or the OLTP system, you typically have a smaller working set of data that often fits into memory. You have small, fast queries with single-digit millisecond or less response times. And you ensure data consistency using primary keys, foreign keys, and data validity constraints. The second is a metrics or an analytics type system, and generally what you'll see is consistently growing data volumes over time. The large amount of data does not fit into memory anymore. Customer interactions require responsive queries, and older data is not read as frequently as new data. And in terms of setting these up and maturing, typically you start with raw inserts, then you move to doing multi-row inserts, and then lastly doing micro-batch inserts using copy as opposed to the actual insert commands. Now that's for the ingestion side or the insert side. In terms of querying better, the first step is to start with partitioning, then moving on to a limited number of targeted index, and then thirdly, creating roll-ups or summary data to be able to query. And lastly, talking about logging and event tracking, because this is usually used for internal purposes. You do ingest data like the metrics analytics. It's definitely a large amount of data, won't fit in memory, but your query response times can be a bit lower. So you don't need to be super fast with it, and you just need to efficiently store all of that data. But definitely interesting post about some recommendations on how you can handle different types of data architectures in Postgres. Next piece of content, running PostgreSQL on 2 ports. This is from thebuild.com. And someone had a situation where they had some clients that could connect with TLS, whereas some could not. and they wanted to separate them connecting to the database using 2 different ports. Well, as he says here, Postgres can only listen on 1 port. So what do you do about that? Well, the recommendation here is you could set up PG Bouncer with TLS turned on. Therefore, those that have that configured, they connect to the PG Bouncer as opposed to the actual Postgres database. And then the other clients could use the unencrypted one. They also talked about using S-tunnel to listen for TLS connections and route them to PostgreSQL. And actually I have a third option. If these clients are separated out with an IP address space, you could actually configure different IP address ranges coming in to go to a TLS connection or a non-TLS connection. So that's another way to handle this as well. But if you have a need to do this, you can check out this blog post. Next piece of content, Docker and sudden death for PostgreSQL. This is from cybertech-postgresql.com. They're talking about a situation they were working with a client, and suddenly PostgreSQL in a Docker container was crashing, and it was saying the server process was terminated by signal 13, a broken pipe. So they're like, that's strange. A broken pipe signal shouldn't be crashing Postgres. So this blog post goes into detail about how they look through and try to identify what the problem was. And basically what happened was that they set up their Docker container using a non-standard way of doing it. So they set it up themselves, and they set up the Postgres Postmaster as the first process to get started. So it starts with a process ID of 1. Now the problem with that, if any other process doesn't have a parent, 1 becomes its parent. So they actually had a PSQL job that would start up periodically that became a parent of the Postmaster process, and it ran into issues basically receiving the signal 13. The Postmaster process monitors its children processes and then takes Postgres into recovery mode if any of its child processes fail. And so this failure brought down all of Postgres. So this failure in a PSQL process unrelated to the server process, it's only associated with it because this lost its parent process, it crashes the whole database. So in terms of avoiding this problem, they say, quote, you could use the official PostgreSQL Docker image, and it does it right by having another process being the process that starts the container, not PostgreSQL. So basically, the Postmaster process won't inherit processes that have lost their parent. And another recommendation is that you shouldn't be starting PSQL processes within the container itself. A container should basically be like a closed unit, as they say here. It's only running that service, and that's the only thing it does. So you could start a PSQL process outside of the container and connect to it for doing work, but it shouldn't be done within the container. But if you want more information about this, you can check out this blog post. Next piece of content, forcing a join order in PostgreSQL. This is from cybertech-postgresql.com. And what they're talking about here is that basically Postgres doesn't have query hints. So the planner assesses the SQL it's received, and it reorders and structures things to try and find the most efficient path to return your data. So it's not going to maintain the table order for your joins that you have specified. It will frequently reorder them. So how could you get Postgres to do what you want to do? Now, there is an extension called PG Hint Plan. So basically, you could install this extension and use query hints, apparently in the style of Oracle here, but he offers some other techniques you can use here. The first technique is using offset 0 to enforce the join order. Now, this seems quite unusual to me, and I don't know if I'd recommend it. And as I say here, quote, it would not be hard to teach the optimizer to ignore this useless clause, and that would disable this trick or this hack, as it were. The next method is using a common table expression to force the join order. So basically you use a CTE and you materialize it. So I personally like this method better if you have a need to do it. And the other option is to set a join collapse limit. So if you drop it down to 1, it will then try not to flatten your joins together, and it will go ahead and follow the join order that you've specified. And it looks like you can do this at the session level. So you could do this within a given session, but not other sessions to your database. And they do have a recommendation to, quote, run the query in an explicit read-only transaction and use set local to change the parameter. And that way it'll revert to its previous setting as soon as the transaction's done. But if you want to find out more about ways to give hints to the planner, you can definitely check out this blog post. Next piece of content, waiting for Postgres 16, logical decoding on standbys. This is from pganalyze.com. And in this next episode of 5 Minutes of Postgres, Lucas discusses the post we talked about last week where Postgres 16 looks like it will have the ability to logically decode on the standby. And this also includes doing logical replication from the standby as well. So if you want to learn more about his perspective, you can check out this piece of content. Next piece of content, Understanding PostgreSQL Parallel Query. This is from stormatix.tech, and this explains in a fair amount of detail how PostgreSQL does its parallel querying and the different parameters that you can change to affect it. Next piece of content, Postgres 15 on encrypted ZFS and Ubuntu 22.04 LTS. This is from manishrajain.com, and he said this is his first time setting up Postgres, so maybe more of the value of this post may be from setting up the ZFS pool. So he goes into detail on how he sets it up in an encrypted fashion using LZ4 compression, and goes into detail on how to set that up as well as installing Postgres as well. Now, the only thing to be cautious of is that I have seen with some clients that at least the compression performance of ZFS, probably encryption as well, really slows down some database aspects. So just be aware of that or test it as you're evaluating it. Next piece of content, there was another episode of Postgres FM this week. This one was on Auto Explain. So they talked about what it is, how it can help, and how to check its overhead. You can listen to the episode here or watch it on YouTube here. And the last piece of content, the PostgreSQL Person of the Week is Hécate. If you're interested in learning more about Hécate and his contributions to Postgres, definitely check out this blog post. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode, or you can subscribe via YouTube or iTunes. Thanks.